So the heart has two parts. It's going to have something that's going to speed up the heart rate, and then there's going to something that's going to slow it down, correct? So what speeds it up? Beta 1, good. So heart definitely has a beta 1. It speeds up. And then there's something that slows it down. What slows it down? Muscarinic. And it slows it down. So if you have something that speeds it up and slows it down, are they equal? No. And that's the concept of predominant tone. So one of them has a bigger effect on the hearts than the other one. And I'm going to talk about exactly how you can deduce that. But for now, you have to know that the heart, in terms of heart rates, is going to be predominantly muscarinic. But let me tell you about this. So this is a good way of doing it. And Judy gave me this really great idea. I give him credit for it. Okay. So if you took someone's heart out, took it out, and then now you're going to say, okay, it has no sympathetic and no parasympathetic innervation whatsoever. What's your heart rate going to be? It's not going to be 0. Okay, so if you got rid of all sympathetic and parasympathetic innervation, what is your heart rate? It's going to be, okay, so here's the thing. I looked this value up, and this value is 100 beats per minute for adult male. You don't have to memorize that. I'm just giving you that value, and it will be easy to see. So first thing is, what is your normal what is your normal heart rate? What's your heart rate? It's like 70, yeah, it's like 70. Okay, so 70 is usually where it's supposed to be. So 70 is resting. Wow, you traveled a lot. Traveled by 30 beats per minute. So this is what I want to show you. First thing is, there's two conflicting forces, beta 1 and muscarinic. Muscarinic, if you put this disembodied hearts and you just gave them acetylcholine, only acetylcholine, then your heart rate will drop all the way down to around 60. It's around like 60, 65, somewhere around there. Around 60. All right, this is going to be parasympathetic. Okay, get rid of that. Okay, so I'm going to get another heart, and I'm going to say, like, I take this heart, it's 100 beats per minute, and then what I'm going to do is I'm going to put something that will only affect alpha 1. Oh, no, beta 1, I'm sorry. Good, you got me. Beta 1. So if I only put beta 1 on, this is what's going to happen. Beta 1 is going to do this. Which one had a bigger effect? Parasympathetic. So if I drew a line over here, which is going to be your baseline disembodied heart, you have two forces. You have a force that's going to bring it up by a little bit, and that's going to be your sympathetic tone. And then you have a big one that's going to be parasympathetic. And they're going to be pulling tug of war with each other. Now, if you put these two in tug of war against each other, who's going to win? Parasympathetic. That's what predominant tone is. Predominant tone means that the way it is right now is really because of mostly, in this case, parasympathetic. Everything has a predominant tone. You must understand that. I'm going to go over all the important ones that you have to know for a predominant tone. Here's a really good thought experiment. So the thought experiment is, what if you got rid of parasympathetic in this case? It's just a thought experiment. I'm going to erase it afterwards. I'm just going to let you think about it. What if I got rid of parasympathetic over here? Would your heart rate be affected a lot or very little? A lot. Okay? What if you got rid of this guy over here? is if you got rid of sympathetic, is your heart rate at resting going to be affected very much? No, it's not going to do much. So like if you got rid of all sympathetic tone, your heart rate's going to be like, oh, it's going to be like 60. But like if you got rid of parasympathetic, bam, your heart rate's going to be at 100, 110. All right? Okay, so what I'm going to be going over is what are the more important predominant tones. So first thing, alpha 1. Alpha 1 has predominant tone on vasculature. There's other ones like sweat glands, genitals, like the point and shoot thing, but really the only one that you really have to worry about right now for these questions are going to be vasculature. What does it do to vasculature? Constricts. Okay, now here's the trick. In terms of predominant tone, the only one that sympathetic has is that one. Everything else is parasympathetic. So what are the other ones that are parasympathetic? So the other ones that are parasympathetic are going to be your hearts. So remember the heart. Well, what does it do? It decreases heart rate. This one increases blood pressure, typically. Okay. What about the eye? What has predominant tone in the eye? Parasympathetic. What does it do? Does it make it small or does it make it big? It makes it small, meiosis. And then finally, you have GI. I mean, these are things that you just gotta know. What does it do? Does it make it constrict or does it make it relax? Constrict. It's going to increase mobility. Alrighty. So I'm going to show it to you in a different way. Just make sure that I got everyone. So heart rate. So this is your heart rate. And let's say that your normal heart rate, once again, okay, so let's say that this is a normal human being. Normal human being. So at normal human, your heart rate is going to be around 70. Okay, now, what are the two opposing actions of heart rates? There's two of them. Shout them out. Beta 1, M2. Good. Beta 1, M2. Muscarinic. All right. This is what they're going to do. They're going to go in, and they're going to say, like, okay, I know that you know what the normal heart rate is. What if I gave this guy a beta blocker? I'm going to say beta 1 blocker. What will happen to the heart rate? Is it going to be a big increase or a small increase? Decrease or increase? Decrease. Good, good, good. Sorry, I forgot that I didn't give all the options for it. So it was 4. Okay, so there you go. Okay, so you have your heart rate like this, and then after your beta blocker has been given one, it's going to decrease, right? Because beta 1 usually increases it, but now you're blocking it, so now it goes down. Does it go down by a lot or it goes down a little, very little? Little, because of what is the predominant tone? Muscarinic is the predominant tone. So if you affect anything else, it doesn't do much. So it will come down a little bit in terms of heart rate. Remember, this is heart rate. And now here's another one, and I'm going to give you the heart rate one more time. And then what I'm going to do is I'm going to give you a muscarinic blocker. Is it going to go up or is it going to go down? It's going to go up. And yeah, it goes up a lot. So it will go up a lot. Alrighty? You got this? All right. Blood pressure. Blood pressure. So now blood pressure is going to be a little bit different. So blood pressure, I'm gonna just make one line. You know, like my normal convention is that like I do a systolic and diastolic. I'm just gonna kind of say like, oh, just total blood pressure for now. So now the blood pressure for this one, they're gonna be affected by several of them. Can you name me what the receptors are going to be? So you have alpha 1, beta 2. Beta 1 does a little bit too. I'm just going to concentrate on but does beta 1 affect predominant tone? Does beta 1 affect, does it affect the vasculature in terms of the predominant tone? Like we're talking about vasculature specifically. So does beta 1 affect vasculature specifically? No, it doesn't. So I'm just going to talk about it in terms of like vasculature. So in terms of vasculature, you have alpha 1, which is going to constrict, and the beta 2 that's going to dilate. Should you consider muscarinic at all? No, why? There is no acetylcholine. Good. High yield fact number 1. Have to know that one. Okay, so alpha 1, beta 2. One of them increases it, one of them decreases it, right? So which one's the predominant tone? Alpha 1. Okay. So with that in mind, I'm going to play that game again. So let's do this. We're going to have two scenarios. I have one scenario where I give you an alpha blocker, and I'll give you a beta blocker. I'm going to write down over here so it's easier. Beta blocker, and then alpha blocker. Okay, so first thing. Alpha blocker, what does it usually do? Well, okay, alpha, what does it usually do? It usually increases your blood pressure, right? But now you're blocking it, so what will it do? It will decrease. Those are the two steps. First thing you know, it does decrease at all. Now, is it the predominant tone? Yes. So will it decrease a lot or decrease a little? A lot. Okay, so alpha blocker is going to decrease a lot. It's going to be great for blood pressure medication. So beta blocker. So beta blocker is beta 2 blocker. I want to just make sure it's beta 2. Okay, so first thing, what does beta 2 usually do? It usually vasodilates. It will decrease. So, okay, so normally it would decrease. But since you're blocking it, what will blood pressure do? It will increase. So now the question is, will it go up a lot or will it go very little? Very little. Know your predominant tone because it's going to come up in different ways. I'm going to show you how it's going to come up very shortly. Finally, I'm going to do one more. Pupil size. Pupil size is not going to be in your. It's not going to be in your algorithm or your tracings at all. But I'm just going to talk about it because it is predominant tone too. So pupil size. So if you have a normal pupil size, that's going to be around that big. I'm going to play the same exact game. Okay, so pupil size, is it going to be sympathetic predominant or muscarinic predominant? Muscarinic. Everything is muscarinic. The only thing that's alpha is going to be vasculature. Anything that is going to be sympathetic the only thing that's sympathetic is vasculature. That's it. That's the only predominant tone. All muscarinic. So muscarinic. So let's say, all right, so muscarinic, first, I'm going to say predominant tone is muscarinic. What does muscarinic usually do? Does it make it big or does it make it small? Small, rest and digest. You're not like running from a bear. When you're running from a bear, it needs to be big, but when you're rest and digest, muscarinic, it should be small. So let's play the same game. So first thing, I'm going to give you, what makes it big? Alpha 1, right? Is it alpha 1? Can you confirm with me? Yeah, it's alpha 1. Okay, yeah. Okay, so the two ones are going to be alpha 1, and then they're going to be muscarinic. All right, so now, first thing, predominant tone is muscarinic. So muscarinic makes it small. So what if you give a muscarinic blocker? Would it affect it a lot? So okay, so first thing is that if you give, muscarinic usually makes it small. But now if you're blocking it, what happens? Bigs. Okay, so now it's big. How big? So is it predominant tone? Predominant tone. So it's going to be really big. So how about if we used alpha 1? Alpha 1? Alpha 1, usually what it will do is dilate it. But since since you're blocking the dilation, you're going to get small, right? Are you going to get small a lot or small very little? Very little. So it's like this eye is going to be practically the same exact size. It's not going to be a really big difference. I'll make the first eye a little bigger just so that you can see that the difference is not very big. Alrighty? Got a good grasp of predominant tone? Okay, now I'm going to put these two concepts together. All right, let me just pause that.